Yes, today's class we will go for another problem related to the greedy method, which is knapsack problem. Let us know what is knapsack problem. So knapsack is nothing but which is a bag, and this bag can hold W units of storage. Okay, so which is nothing but like this one bag is there. This bag can hold only W weight items. If it is more than W weight item, I cannot store into this bag. This is first condition. Next, using this bag, you have visited one store. The store contains some set of items like I1, I2, I3, and so on. IN items are there. So from these IN items, so each item is associated with its weight. W1, W2, W3, and so on. Wn weights are there, which is nothing but I1 is nothing but, for example, rice. I1 item is rice. W1 is nothing but 50 kg, which is nothing but in this store we have one item that is rice. Rice contain 50 kgs quantity of item is present inside that store, which is represent that one. So I3W3 is nothing but I3 item which has 43 weight of storage is available inside the storage store. So next one, if I purchase this W1, or if I purchase this I1, total W1 weight. Okay, so I will get the value that is V1. Means if I purchase these 50 units of rice, I am going to get the value, this is 100 rupees or pounds, you can take anything. So like that, its value is V2, its value is the V3, and we have Vn values. So now actual knapsack problem will start. So here, what does knapsack problems do? So here, condition 1 I am saying. The condition 1 is I need to select some set of items from this store. Okay, and I need to start off filling these items into my bag or my knapsack. So while filling items into this, the sum of these items weight should not exceed this knapsack weight. That is first condition. Means selected items value should not exceed knapsack weight. This is first constraint. And the second condition I am writing. The second condition is greedy method. So what is that? What items and weights you have chosen whose value should be the maximum value. Okay, if I take any other combination, that combination should not get the best value. Okay, so maximum value, okay, I should get. This is comes under the maximization problem. And what is the maximization value you get? This one is the optimal solution. So you never get best solution than the solution you find using this greedy method. Let us know what are the types of knapsack problems are there. So first knapsack problem is 0 by 1 knapsack problem. Second one is fractional knapsack. What is mean by 0 by 1 knapsack problem? 0 by 1 means, so the item which you have chosen, either you fully included or excluded, but you can't take part of that item. Example, I want to purchase one mobile. Okay, so this is my mobile, and this mobile weight is, for example, 50 grams of mobile is there. So my container can hold only 20 grams of storage. Then can I keep this item into my bag? No, because it is exceeding. Okay, so can I take part of this mobile? Can I break down that mobile and kept the 20 grams piece in my container and remaining 30 grams in store? No, it is not the correct way. Okay, so either I pick the item or I exclude the item. So that is said to be the 0 by 1. So 0 which is represent excluded, 1 is represent included. Okay, this is next one, fractional knapsack, which is nothing but the item you have chosen you can divide and add the fractionally. Now I will go for one other item. So this item is rice. Okay, how much quantity of rice is available? For example, 10 kgs of 10 kgs quantity of rice is available inside a store, but you have container which can hold only 5 kgs storage. Then what you do? From these 10, can you take only 5 units and can you keep into your knapsack or not? Yes. So this type of problem is said to be the fractional knapsack. This type of problem is said to be the 0 by 1 knapsack problem. So this 0 by 1 knapsack problem we will learn in the dynamic programming. Dynamic programming concept, and fractional knapsack we are learning right now, that is greedy method. Tell me whether it is minimization or maximization. This is maximization. Maximization means what are the items I have chosen whose value should be the maximum. Okay, let us see how to do this one. I will show you one example. So here this is fractional knapsack problem, and I have items. That items are A, B, C, D, E, F. These are the item names, and capital A contain 10 units of weight. 10 units weight of item is available inside a store, and if I take these 10 units, I will get 60 rupees of value. So similarly, each item has its own weight and its own value. Let us know how to compute this one. And next one, what is the next thing? Knapsack. What is the knapsack weight? 50 units. So I am going to draw 50 units storage knapsack. Okay, so this is 10 units, this is 20 units storage, this is 30 unit, this is 40 units, this is 50 units. So this each line represents 10 units of storage it is available. Okay, so is it mandatory to draw that lines? Means no need, just for graphical representation. Next, how can I choose the item from this one? So here you cannot decide by seeing the total value. If you take the total value directly, you definitely get problem. You never get the optimal solution. To get the optimal solution, initially you need to find each item unit weight value. Okay, what is the step one? Step one, I need to find the value of unit weight. Unit weight is nothing but, so here which contain 10 units of weight, then I will get 60 units of value. So instead of 10 units, I want to find for 1 unit. Let us know how to compute this one. So unit weight value I am going to find. How can I find? Total value divided by how many units of weight available. That I need to find. So here this is total 60 units of value, and 10 units of weight available of capital A. Then unit weight is 6. Second one, 100 divided by 20, total 5 units. Next, 120 divided by 30, total weight is unit weight is 4. Unit weight is 4. Next, 90 divided by 25. So 25 3 ja 75, remaining 15. So 25 6 ja 150. So you will get 15 is filled. Next one, 75 divided by 15. So 15 5 ja 75. Next, 150 divided by 40. So 0 0 cancel, 15 by 4. 4 3 ja 12. You have 3. So 4 7 ja 28. 29 32. 4 5 ja 20. Right. 3.75. So these are the unit weights. Next, once you find the unit weight, step 2, you need to arrange these all items according to the unit weight. In which order? Descending order. So we need to sort the data, okay, according to the unit weight. So in which order we need to sort? Descending order. Okay, let us know how this data set has changed. So here I am going to write this one. This is item name, and here this is weight, and this is value. This is are the total values, and this is value of unit weight. So this is unit weight. So first, what is the best value? 6. So I am taking 6. Its total value is 60, and weight is 10, and item name is A. What is the next best? 5. Here 5 is available, here 5 is available. So even you take B, there is no problem. You can take E also. So you can take any item. There is no any constraint that you should write B followed by E or E followed by B. So when the unit values are same, you can take any order. It doesn't matter. So I am going to take B item, so whose unit value is 5. So total 100 value. When do you take 20 weight, 20 units of weight? Next one, next 5, which contain total 75 value. 15 units of weight is available, and item name is E. This one is also completed. Next, what is the best? 4. 4, which contain 120 units of value, which contain 30 units of weight, and item is C. 4 is also completed. Next, 3.75. 3.75. Next, whose total sum is value is 150. Next, its quantity available is 40 units, and item name is F. And next one, 3.6, and the total value is 90, and 25 units storage is there, and item name is capital D. So this is the way I have rewrite that given data into this format. Next, I need to select these items and fill into this what is the container, and let us decide what is the total value. So I am going to find the total value. So my requirement is to know only total value. So I am going to take what items you have included into that knapsack also I will tell you. So first one, which item I need to choose? Capital A. So how much weight of capital A is available inside store? 10. So here these 10 units I am going to fill with the capital A item. Okay. So remaining 1, 2, 3, 4, 40 units of storage still available inside the container. So what is the profit I get when I choose this capital A? 60 units total value I got. Next plus. What is the next item I need to choose? This 5 unit weight. So how much weight is available? 20. So can I store this 20 out of 20? Yes, definitely. So I am going to fill this 20 units. This 20 units is capital B, and remaining 20 units storage still available. So how much, what is that? Value I got 100 plus. This item I have chosen, this one I have chosen. Next, what is the next thing? E item. So how much quantity it is available inside store? 15 units. How much free space is still available? 20 units. So here I am going to fill this 10 units plus this 5 units. So this 15 units is filled with the item number E. So what is the total profit I get? 75 plus. Next, how much free space still available? 5 units of free space. So how much quantity it is available? C item 30. So can I pick this 30 out of 30? No. So is it fractional or non-fractional? This is fractional. So that from 30 I can take only 5 units of weight. So that 5 units of weight is going to be filled at this place. Okay. So this is which item? Item number C. How many units I have taken? 5 units. What is the each unit weight? 4. 4. So this is 60 plus 100 plus 75 plus 5 for the 20. So 5. Next is 7 plus 2 9. 9 plus 6 15. 1 2. 225 units of value you will get when you go for this combination. And if you take any other combination, you never get more than 255. So this is the best solution, or you may call it as optimal solution according to the greedy method.